In this video, we are going to solve absolute values, and we can do this in two ways, graphically or algebraically. If you want to solve this algebraically, there are always two cases you need to consider. One case is the expression inside the absolute value symbol is positive or zero, and then the other case is the expression inside the absolute value symbol is negative. So we're going to take a look at those two cases when we're going to solve for our absolute value algebraically. But first, we're going to do this graphically. So when you're doing this graphically, you're going to graph both y equals 7 and y equals the absolute value of x minus 3 from our first example. And we're going to graph them on the same graph. Then we're going to look at the points of intersection, and this will determine what our solutions are going to be. I'm going to start off by drawing in my x and y axis and labeling them. So I'm going to graph y equals 7 right away. This is a horizontal line. And then for my absolute value graph, we can determine one of our points, just like how we would read a quadratic. So we have a point at 3, 0. And this point is the point in between those two lines that create that V shape in our absolute value. In other words, this is called the invariant point. Then we can find other points. You can do a table of values if you want, so you know how to graph this one. But if you know the shape of your graph, it's pretty easy. You just go up 1 over 1 on both sides to find the next point. So those are our two graphs. Now we're going to look at the intersection points. So there's one here and one here. Then we can write our solutions in terms of x. So one intersection occurs at x equals -4, the other intersection occurs at x equals 10, and that would be our solution. So solving absolute value equations graphically sometimes will give us only the approximate solutions. If we want to find the exact value solutions, we do need to do it algebraically. So we're going to use the definition of absolute value to create two new linear or quadratic equations, and then we'll solve for them. So this was our equation to begin with. We're going to consider two cases. It's very similar to what we've been doing in the other lesson when we're trying to find our x-intercepts. So the first case is just x minus 3 is equal to 7. The other case we need to consider, case 2, is the negative of x minus 3 and how that equal to 7. So these are our two cases. So basically you're taking whatever is on the inside of the absolute value. Case 1 would be as what you see, and then case 2 is going to be the negative of that, and make sure you include that all in brackets. Now we're going to solve each individually. I can add 3 on both sides. That's 7 plus 3, which is 10. That's one solution. The next one, I'm going to distribute the negative. That's negative x plus 3. Move things around. That's 3 minus 7 is equal to x, which is -4. And that's our other solution. And as you can see, that's the same thing that what we got when we did it graphically. We had x equals -4 and x equals 10. So I want you to try the next one on your own. It's very similar. I want you to try it graphically and also algebraically. So go ahead and do that, and then when you're ready, press play. So for graphically, you want to graph both the absolute value of 6 minus x, and then you also want to graph the horizontal line 2, y equals 2. So I did do that, and then when I look at the intersection points, they intersect at x equals 4 and at x equals 8. Remember that we always want to talk about our solutions or state our solutions as x. and we don't really care about the y value in this case. Now looking at this algebraically on the left-hand side, the first case is 6 minus x equal to 2, and then case 2 is negative in brackets 6 minus x is equal to 2. And then we would rearrange and solve for both, and we got the same answer, x equals 4 and x equals 8. Let's do another example together. So there are again going to be two cases. Case 1 is exactly how I see it, but without the absolute value. For case 2, I'm going to take this 2x minus 5 and put a negative in front of it. So I'm considering the case when 2x minus 5 is negative. And we'll solve for each. So going back to case 1, I'm going to move the 3x to the other side. Move the negative 5 to the other side. 5x is equal to 10. Divide both sides by 5. Our final answer is 2. Now let's do the other case. I'll distribute this negative to both terms. And then rearrange and solve for x. We can see that 5 minus 5 is 0, so right away we know just x is equal to 0. And that is the other solution. I want you to try the next one on your own. It's very similar to the example we just did. So go ahead and do that, and then when you're ready, press play. Here is case number 1. It's going to be 3x minus 4 plus 12 is equal to 9. Rearrange and solve for it. X is 1/3. For case 2, you're going to put a negative in front of 3x minus 4, all in brackets, and then solve for it. You should get x equals 7/3. Moving on to example 4. This is a slightly different question because if you take a look at the inside of our absolute value sign, we have a quadratic. So we're going to do this graphically first. What we're going to do first then is look at the intercepts of x squared minus 2x, the absolute value of it. So I'm just going to look for the x-intercept first by setting y to 0. Usually we just have two cases if this were to occur. So case 1 is going to be x squared minus 2x is equal to 0. We would factor this. So x is equal to 0 and 2. And then you could do a case 2, but you just get the same thing, x equals 0 and 2. So you can go ahead and do it if you want to, but you would get the same thing. So those are our x-intercepts. And if you look for our y-intercept is also just going to be 0, just because we already have x equals 0 here. So then the next thing we're going to do is look for points. And we'll use a table of values. So I'm just going to quickly draw these 2 points that we just found. So we have one here, and we have one here. So I need to look for something on the left-hand side of x equals 0. Let's just say -1. I can look for that one. And then I'm going to look for x equals 1, and then x equals 3. So one that's on the left side of the point, one's in between the 2 points, and then one on the very right side of that point. And we're going to plug this into our x squared minus 2x, the absolute value of it. And this will determine our y value for that coordinate. So this is going to be 1 plus 2, which is 3. Then I'm going to do it for 1. This will be 1 minus 2, which is absolute value of -1, and that's going to be just 1 then. And then we'll try it for 3. That's 9 minus 6, which is absolute value 3, and that's 3. So now we're going to plot those points. And then we're going to connect our points from left to right. And put arrows on each side. So again, notice because this is based off a quadratic, the curve should be curvy and not pointy. So make sure that when you're connecting to this point over here, that it's nice and curvy and not pointy. Then the next thing we want to do is graph our y equals 1 line, which is over here. Finally, we're going to look at the intersection points to see what our x values are. So we're going to get x equals 1 for sure. And then looking at the other two intersection points, we have one over here and one over here. We are just going to have to approximate it because we don't know the exact point it is touching at. So we can say about maybe 0.5 as one of them, and the other one could be 2.3. And that's just an approximation. Now, if we want to know the actual value for those x ones, we're going to have to do this algebraically. So again, there's two cases then to consider. Case 1 is going to be x squared minus 2x is equal to 1. Case 2 is going to be negative x squared minus 2x, which is equal to 1. So we are going to factor here, or use the quadratic equation depending on what we have. So looking at this one, we cannot solve this by factoring, so we are going to use the quadratic equation. Our b value is negative 2. Plus or minus b squared minus 4ac all over 2a. So that's 2 plus or minus negative 2 squared is 4, then plus another 4 all over 2, which is 2 plus or minus the root of 8 over 2. Put this in our calculator, we're going to get 2.414 and negative 0.44. So this is a one set. Now I'll try case 2 and see what we get. We're going to distribute that negative to the two terms. And then I'm going to move things around and then factor. This one we can factor. Going to be x minus 1, x minus 1, so our x then is 1. So if you take a look at what we had before, in this one, it's pretty close. We got negative 0.5 and 2.3, but the actual value of it should be negative 0.44 and 2.414. Just one more example here. We're going to solve this algebraically. So we're going to consider case 1 and case 2. So case 1 is just x minus 10 is equal to x squared minus 10x. Case 2 is negative x minus 10 in brackets, and then this is equal to x squared minus 10x. We're going to rearrange our case 1 so we could solve for x. We're going to get everything to one side, and the other side is just going to be 0. So I just moved the minus 10 to the other side and the x to the other side. And then I will collect my like terms, and then we'll factor. So factors of 10 are 5 and 2, but that won't give us negative 11. The other one we can use is 10 and 1, and if they're both negative, we can get negative 11 from that. So then x is equal to 10 and 1. Now we'll look at case 2 and distribute the negative here into the two terms. Then I'm going to move things around so that we have 0 on one side and everything else on the other side. So I'm going to add x to both sides and then minus 10 on both sides. Collect my like terms, and then we'll try to factor this. We can use 10 and 1 to get 10. And for a middle term, this would be fine if we had a negative 10 and a positive 1 to achieve a negative 9. So then x is equal to 10 and negative 1. So if you want to summarize all of our answers, x is negative 1, 1, and 10.